Welcome to this course on the analytical modelling of shell structures. My name is Dr. Sean Carroll. I'm a structural engineer and the founder of EngineeringSkills.com. In this course, I'm going to walk you through the fundamentals of membrane shell behaviour, from the basics of Hooke's law all the way up to analysing compound multi-shell structures. Shells are some of the most efficient and elegant structures we get to work with as engineers. As long as humans have been building large-scale structures, we've been taking advantage of the amazing ability of shells to span large distances with remarkably thin section depths. Now, what makes shells such efficient structures is their ability to resist external loading by developing membrane stresses. When a shell is well designed, bending stresses are minimized in favor of direct membrane stresses. In this course, you'll learn how to model membrane behaviour and predict the stress distributions and displacements of common shell geometries, from spherical and hyperboloid shells to multi-shell structures. Beyond the membrane behaviour of shells, you'll also build up your ability to unlock dense mathematics using Python. If you've tried to tackle shell analysis in the past, you'll know that it's not long before you're met with a wall of heavy mathematics. One of the aims of this course is to show you that with the right tools and an understanding of the fundamentals, this doesn't have to be a barrier. If you're new to Python, that's not a problem. No one ever learned Python by watching lectures about Python. You need to actually use it for something, and this course is a great vehicle for you to get comfortable using Python for engineering analysis. You'll pick up everything you need in terms of Python as you move through the course. So, if you want to know how shell structures do what they do and build a toolbox of analysis techniques to predict their behaviour, join the course and I'll see you inside.